People don't care how much you know until they know how much you care. A tele-reminder from Teleradyo Marcelo, ang telearalan ng bawat Malulenyo.
Magandang araw, Delphilarians!
Sa taong po ito, pag-iniwan natin ang isang radyo, mabuhay ang Pilipinas.
Makinig, manood na sa teleradyo. Makinig, manood na sa teleradyo. Teleradyo, Teleradyo Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo, sa programang ito.
Quarter ng year na ito, ako din excited ng turuan kayo. Kaya ano pang hinihintay nyo mga batang Malulenyo? Tara, mag-aral tayo dito sa Teleradyo Marcelo. Hello and good morning, Delphilarians. Welcome to the Q4 Week 4 Teleradyo Marcelo episode of Mathematics 8, ang telearalan ng bawat Malulenyo. This episode is made possible by the Teleradyo Marcelo team and the Junior High School Mathematics Department. Again, I am Mr. Richard M. Cruz, your Mathematics 8 teacher broadcaster, to supply your weekly dose of fun, exciting, and informative math ideas. For today's episode, we will discuss Q4 Week 4 lesson entitled Determining the Conditions Under Which Lines and Segments Are Parallel and Perpendicular. So we would like to get the attention of the grade 8 students, especially those who experience difficulties in understanding the lesson. Okay. Throughout the episode, we will learn how corresponding angles, interior and exterior angles, are used in theorems to prove parallelism and perpendicularity. So, bring out your paper, pencil, and snacks. Take your most comfortable seat and let's get started. Let's take a quick review by discussing this concept map. You may post your answers on the comment box with your full name and section. This concept map is about the triangle inequality theorems, which are divided into two parts. The first part is inequality for one triangle, and the second part is the inequality for two triangles. For the one triangle, we have four inequalities, namely theorems 1, 2, 3, and the exterior angle inequality. For the two triangles, we have the hinge theorem and its converse. Okay. Do you remember theorem number 1? Yes. Theorem number 1 states that, okay, the longest side is opposite the largest angle, or the shortest side is always opposite the smallest angle. How about theorem number 2? Theorem number 2 states that the largest angle is opposite the longest side and the smallest angle is opposite the shortest side. Okay, those are theorems 1 and 2 involving the sides and the angle of a triangle. How about theorem number 3? Theorem number 3 for triangle inequality of one triangle states that in any triangle, the sum of the lengths of any two of its sides is greater than the length of its third side. So, if we add the first side and the second side, it should be greater than the third side. Next, for two triangles, we have the exterior. Again, for the one triangle, sorry, that's the exterior angle inequality theorem. And it states that the exterior angle is always greater than the remote interior angles. Remember that we have two remote interior angles. If we add them, that is equal to the exterior angle or the measure of the exterior angle. Going back to our two triangle inequalities, first one is the hinge theorem. The hinge theorem, or also known as the SAS triangle inequality theorem, states that if two sides of a triangle are congruent to two sides of another triangle, and the included angle of its first side, first angle is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. It means that if the hinge is opened wider on the first triangle compared to the second triangle, it means that the angle is greater and the opposite side is always greater. Lastly, for our two triangles, we have the SSS triangle inequality theorem. Please take note, this is different from the SSS triangle congruence postulate because we have here two congruent sides or two corresponding sides, but one different side on each triangle. Okay, it states that if two sides of a triangle are congruent to the two sides of another triangle and the third side of the first is longer than the third side of the second, then the included angle in the first triangle is greater than the included angle in the second triangle. It's as easy as that. I hope you can recall those lessons that we have involving the triangle inequality theorems. Do you know what is that? Yes, those are the imaginary lines in our hemisphere. Since our Earth is spherical in shape, we can draw imaginary lines like the longitude and the latitude. Okay. What is the main longitude? Yes, the main longitude of our globe is what we call the prime meridian. The prime meridian passes the Greenwich, England. That is a town in which we can refer to our timeline. And the latitude, the main latitude is the equator. The equator passes through the countries like Ecuador, Africa, some parts of Africa, Indonesia, and some parts of Asia. Those are imaginary lines similar to our lesson for today. And we will have our learning guide. For this episode, we will illustrate parallel lines cut by a transversal. Actually, this is a review from your grade 7 mathematics lesson. And we will recall the terms describing the positions of congruent and supplementary angles. We will also illustrate the parallel and perpendicular lines postulates, as well as identifying the postulates or theorems that guarantee parallelism or perpendicularity of lines in parallel lines cut by a transversal. So, what are parallel lines cut by a transversal? Do you remember these lines? Let's say, for example, we have line A and line B, which are parallel. Parallel lines do not cross or do not intersect. They do not meet each other. They do not meet each other, whatever line you extend to them. And it was cut by line C, which is what we call the transversal. Now, we can identify different angles. 1, 2, 3, 4, 5, 6, 7, and 8. Angle 4 and angle 3, as well as angle 5 and angle 6, are what we call the interior angles, obviously because they are inside those parallel lines. How about the exterior angles? Those are angles 1, 2, 7, and 8. Yes, of course, they are outside or the exterior part of those parallel lines, A and B. Next, we have what we call the alternate interior angles. What are the alternate interior angles? On this figure, we have angles 4 and angle 6. Angles 4 and 6 are congruent. They are equal. That's why alternate interior angles are congruent. We can have also another pair. That is angle 3 and angle 5. Angle 3 and angle 5 are alternate interior angles and they are congruent. If angle 3 is equal to 75 degrees, therefore, angle 5 is also equal to 75 degrees, for example. And we also have the alternate exterior angles. Those are, for example, angle 2 and angle 8. They are congruent. As well as another pair, angle 1 and angle 7 are congruent because they are alternate exterior angles. How about the same side interior? Angle 3 and angle 6 are same side interior angles. And angle 4 and angle 5 are also pairs of same side interior angles. Now, what do you call angle 2 and angle 7 as well as angle 1 and angle 8? Yes, they are same side exterior angles. There you go. Same side exterior angles are supplementary by pair. We also have corresponding angles. Angle 2 and angle 6 corresponds each other. If we have corresponding angles, obviously, they are congruent. Can you name or can you identify other pair of corresponding angles? Let me see your comments. Can you please mention or identify corresponding angles? Okay, we have audiences from grade 8 SPA 1, angle 1 and angle 5 from Von Eisen Cordovilla. Very good. Those are corresponding angles. Yes, also from Princess Altea Valdez from grade 8/1. Very good. Also Rain Panganiban from grade 8/1. We also have an answer from Kent Irvin Akuyong, angle 4 and angle 8. Very good. Those are also corresponding angles. Okay. Kent Irvin Akuyong also answered angle 3 and angle 7. Very good. Okay. We also have answer from Jan Loren de Guzman, Micaela Calayag, Andre Fajardo, Maria Claudia Christine Ray, James Cruz, Roy Carmela Cua, Gabriel, Adriana Chloe Demission, Mark Jacob Ramos, Mariel, and Rain Panganiban. Angel Joy Panganiban. Thank you for your participation. Next. Let us now discuss the parallel postulate. We have here the definition of the parallel postulate from Euclid's book, Elements. Given a point and a line not containing it, there is exactly one line through the given point parallel to the given line. Two lines are parallel if and only if they are coplanar and they do not intersect. That is the symbol used for parallel lines. But how do we illustrate that one? Given that we have line A and a point outside that line A is point X, there is only one line that passes through point X parallel to line A. And we can call that as line B. Therefore, line A is parallel to line B. Let's say, for example, we have another point, point Y, and we can create a line parallel to line A that passes through line point Y. And we can call that as line C. Line A is parallel to line C. How about if we defy that postulate? Using point Y and extending a line that is not parallel, let's say for example, line D, line A is not parallel to line D. Or using the point Y and we extend the line E, line A is not parallel to line E. Therefore, using point Y, there is only one line, that is line C, parallel to line A. And the parallel postulate also states that two segments are parallel if and only if the lines containing them are also parallel. Let's say, for example, we have two lines and we define two segments or one segment on each line. And we name them as segment MN and segment OP. If those lines are parallel, therefore, those segments are also parallel because they are contained on parallel lines. And we can now state that segment MN is parallel to segment OP. There you go. How about the perpendicular postulate? Given a point and a line not containing it, there is exactly one line through the given point perpendicular to the given line. And that is the symbol used for perpendicular lines. How do we illustrate perpendicular postulate? Please take note that when we say perpendicular, we are having a 90-degree angle or a right angle on the intersection. Let's say we have line G and a point Q outside that line. Passing through line G from point Q, we have line H that creates 90 degrees. Therefore, there is only one line that can create that 90 degree on line G. And line G is perpendicular to line H. How about if we have line I that also passes through line Q, but it does not create 90 degrees? Okay, line I is not perpendicular to line G. How about line J, the yellow line? Using that point Q and passes through line G, but it does not create 90 degrees, line J is not perpendicular to line G. Now, let us discuss some postulates and theorems that guarantee parallelism and perpendicularity on parallel lines and perpendicular lines. The first one is what we call the CACP. The CACP stands for corresponding angle congruent parallel postulate. Please take note, we have corresponding angles and we have a review on the previous slides. Given two lines cut by a transversal, if corresponding angles are congruent, then two lines are parallel. Suppose we have line M and line N, but we do not state that they are parallel, and a transversal line T cuts those lines, identifying the angles 1, 2, 3, 4, 5, 6, 7, and 8. Let's say, for example, we have angle 4 and angle 8, which are corresponding angles, we can state that if angle 4 is congruent to angle 8, then line M and line N are parallel to each other. Again, if angle 4 is congruent to angle 8, then line M is parallel to line N. What are other corresponding angles that you can identify so that we can conclude that angle M is parallel to angle N? I will read some comments from our Facebook Live. We have audiences from grade 8 Kisumbing, very good. Also from grade 8 CP Ferrer, grade 10 IG Garcia, grade 8 Nakpil. Okay. We also have audiences from grade 8 RDC Jonicio. Thank you so much. And an answer from Ashaila Rispangan, 6 and 1. 6 and 1 are not corresponding angles. Sorry. Okay. Angle 2 and angle 6, an answer from Rain Panganiban. Very good, from grade 8/1. They are corresponding angles. So, Rain, you can use if angle 2 is congruent to angle 6, then line M is parallel to line N. That is how you will state. Okay. We also have answers from John Loren de Guzman, James Cruz, Mariel, and Ronaldo E. De Leon II. Also from Hale Avila, John Gabriel Tanghal, Adrian Claude Aguilar, Tara Roque, Denise Francesca. Okay, very good. Thank you so much. Ralph Nathan Mansilungan. Great job, guys. So that we can conclude that line M is parallel to line N by corresponding angle congruent parallel postulate. Please take note, we are using corresponding angles given that we have parallel lines or two lines cut by a transversal. Next, the AICP theorem, or what we call the alternate interior. Please take note, alternate interior congruent parallel theorem. Given two lines cut by a transversal, if alternate interior angles are congruent, then the lines are parallel. Let us identify alternate interior angles. Okay, so we have angles 4 and 6. We can now conclude that if angle 4 is congruent to angle 6, then line M is parallel to line N. There you go. Since angle 4 is congruent to angle 6, which are considered alternate interior angles of two lines cut by a transversal, therefore, those lines are parallel, in which in this case we are using line M and line N. Can you identify also some alternate interior angles that can be used for our statement so that we can use the theorem AICP, or alternate interior congruent parallel theorem? Did you answer angle 3 and angle 5? Let's use those angles. So we can have the statement, if angle 3 is congruent to angle 5, then line M is parallel to line N. There you go, as easy as that. Next, third one is the same side interior angle supplementary theorem, or the SSIAS theorem. This theorem, given two lines cut by transversal, if same side interior angles are supplementary, then the lines are parallel. Please take note, if we are using same side interior angles, By this time, we will be using angle 4, 3, 5, or 6 angles. Okay? We can use angle 4, 3, 5, or 6. Those are the interior angles. But which are the same side interior angles? And please take note that they are also supplementary. Okay. For this example, we have angle 4 and angle 5. Okay. Sorry for this technicality. If angle 4 and angle 5 are supplementary, please take note we will not use the congruent symbol. Okay? Please take note again, we will not use the congruent symbol. This is a typographical error. So if angle 4 and angle 5 are supplementary, let's say for example, angle 4 measures 100 degrees and angle 5 measures 80 degrees, which are a total of 180 degrees, proven that they are supplementary, then line M is parallel to line N. What are the other same side interior angles can be used for this SSIAS theorem? Did you answer angle 3 and angle 6? If angle 3 and angle 6 are supplementary, then line M is congruent to line N. Please take note of my uh, correction. We will not use the symbol congruent. Okay, next one. We have AICA or alternate interior corresponding angle theorem. What does it mean? The AICA, given two lines cut by a transversal, if alternate interior angles are congruent, then corresponding angles are congruent. Please take note, we will use alternate interior angles. Then, one of its corresponding angle is also congruent. Okay, let's say for example, we have the alternate interior angles 4 and 6. We can have, if angle 4 is congruent to angle 6, then angle 6 is congruent to angle 2, which is the corresponding angle of angle 6. Can you please mention another corresponding angle or alternate interior corresponding angle theorem? Let me read some comments from the Facebook Live. Okay, we have audiences from grade 8/1. Okay, from RDC Dionisio. From Kent Irvin Acuyo, angle 4 and angle 6. Angle 3 and angle 5. Okay, those are alternate interior angles. Very good. Angelo Lidon, Lagi, angle 3 and angle 5. Very good. They are alternate interior angles. If you are using angle 3 and angle 5, okay, therefore, angle 1 is, or angle 1 corresponds angle 5. Okay. Thank you so much for your participation, class. Okay, we have from Precious Marine, Janelle Carpio, Adriana Chloe Dimison, Vincent Maren Magsakay, Tara Roque, Aisel Daphne Avendaño, Angel Joy Panganiban, Erwin Fabian, Andrea Kit de la Cruz, Ashaila Reese Pangan, Linus Ian James Lobrino, very good, angle 1, 5, and 7. Okay. That can be considered, but they are not alternate interior angles. Okay. Some of them are vertical angles, but they are also congruent. Very good. Okay. Thank you for your participation, class. Next, the three parallel lines theorem. In a line, if two lines are both parallel to a third line, then they are parallel. Let's say, for example, we have lines M and N cut by a transversal line T. And we have another line, the third line, line L. Okay. If line M is parallel to line N and line N is parallel to line L, then line M is parallel to line N. Okay, parang tongue twister ito, no? Okay. But it's as easy as that. If two lines are parallel and another pair of lines are parallel to one of its lines or the considered line, then all of those three lines are parallel. We will not consider what's this how the space in between them. As long as they are parallel or they do not intersect, if we extend them, they are parallel or the three lines are parallel. The perpendicular to a third line theorem states that if two coplanar lines are perpendicular to a third line, then they are parallel to each other. Let's say, for example, we have line M and line T intersects line M that creates 90 degrees, and another line N intersects the transversal line T, creating 90 degrees. If line M is perpendicular to line T, which is our first example, and line N is perpendicular to line T, therefore, M is parallel to N, or line M is parallel to line N. Okay, it's as easy as that. Line M is parallel or perpendicular to line T, and line N is perpendicular to the same transversal line T, creating 90 degrees on both angles on each intersection, then those lines are parallel, which is by this time our example is line M and line N. Okay, let's check our learning guide if we achieve those ideas. Okay, did we have our goals? Did we illustrate parallel lines cut by transversal? Yes, we have two lines cut by a transversal. Please take note that parallel lines are lines that do not intersect and that transversal is the third line that cuts them into parts, having different angles. We also recall the terms describing the positions of congruent and supplementary angles. We have the interior angles, the exterior angles, the same side interior angles, the same side exterior angles, the alternate interior angles, and the alternate exterior angles. Some of them are congruent or gives congruent pairs of angles, and some are supplementary pairs. We also illustrate the parallel and perpendicular lines postulate. Let's say, for example, if we have a parallel line, it means that there is a line and a point containing that line which are parallel. There is only one line that can be used that passes through that point parallel to our reference line. The same as our perpendicular line postulate. If we have a line and a point outside that line, extending that point given that line, creating 90 degrees, there is only one line that can create perpendicularity to that reference line. We also identified the postulate theorems that guarantee parallelism or perpendicularity of lines. Okay? And now you are ready to answer the learning activity sheet assessment. That is on page 37 and 38, numbers 1 to 15. Please use the answer sheet. Okay? Thank you. Now, let us discuss the performance task required for our quarter 4. That is the ladies' fan and the carnival map. You can take a break for us to discuss the performance task. Please get your references, your learning activity sheets, and we will discuss this performance task. Okay, do you now have your copy of the performance task? Okay, let me get my own copy of performance tasks. Okay, the first one is the fan making or the ladies fan. Okay. So, suppose you are an artist in a fan making industry. Sikat na sikat ito lalo na last week which is napakainit. Kailangan natin ng pamaypay tuwing lalabas tayo or kaya nasa loob ng bahay. And the management ask you to make a design of a fan which will be imported to other country. Wow. Okay? So, pwede itong export quality or import quality. He required you to make a creative and affordable fan. So, you can use different materials such as sticks, cartons, papers, plastics, or any materials that can be used to create this fan. You have to submit the fan for evaluation under the following criteria. First is the presentation. It should be creative, malinis, neat. Okay. The time and effort in making this fan. You can also ask assistance from your parents or from your guardian. Of course, timeliness, it should be submitted on time. Please ask your teacher regarding the due date or the deadline of this one. And of course, lastly, it should be durable and of course, it is useful. Hindi naman pwede na, okay, nakakapag-create ka nga ng isang magandang pamaypay, nakasubmit ka ng on time, magaling ang effort, kitang-kita na naghirap or pinagbigyan ng oras, pero isang paypayan mo lang ay hindi na magagamit. That is a no-no. Minus points yon. And usefulness. Okay? So it should be something that can be used. And the last one is the Carnival Vicinity Map. Do you remember visiting Enchanted Kingdom? Yes. Meron silang pinapamigay na mapa para hindi ka maligaw. Okay. So the city mayor would like to build a carnival in your hometown. Let's say in Malolos. The purpose of this project is to boost the town's economy, to promote tourism, and to reduce the number of unemployed graduates. Okay, maybe after this pandemic, if we have vaccinated or the vaccine is achieved by the government, we can now have our own carnival. But of course, you will create the carnival vicinity map. How are you going to design that one? And you will be a member of the city planning team. Your job is to create the vicinity map to show the location of the carnival. The vicinity map you will create will be put at the back of the flyers to be distributed 1 week before the opening of the carnival. That is a nice presentation. Okay, you should follow the following guidelines in creating the vicinity map. First, parallel lines, transversal lines, and perpendicular lines should be evident in your vicinity map. Of course, you may use parallel lines, perpendicular lines, and transversal lines to create those roads. Special angle pairs are marked specifically by placing buildings as trademarks. And each street and building should be labeled. The location of the carnival should be easy to find. Okay, so you are going to submit your work to the head of the city planning department for evaluation under the following criteria: accuracy, presentation, and explanation. Now, for PETA 1 and 2 or performance task 1 and 2, which is the ladies fan and the carnival vicinity map, you are expected to submit a PowerPoint presentation, a video, or a document file to your respective teacher. It's up to you which one is easier and most comfortable for you. And please be creative for this performance task. Okay? And this lesson really takes too much activity for your brain cells, right? So better use it than just keep it. Now I challenge you to answer the assessment part of week 4 on your answer sheet to test your math skills acquired during the discussion. So good luck. Maybe you have some topics or points that aren't clear for you. Don't worry. The Teleradio team will upload this episode on Facebook and YouTube. So don't forget to follow, subscribe, and click like, share this video on our Facebook page and YouTube channel. No available resources for our social media platforms? Your respective mathematics teacher got you. We have Ma'am Emma Garcia, Ma'am Pearl Laksa, Ma'am Charito Ferrer, Ma'am Chelsea De Luna, Sir Emer Narciso, Ma'am Lani Reopirio, Sir Marlon Atienza, Ma'am Lizelle Pagio, and of course, yours truly, Sir Richard Cruz, to entertain your questions through Messenger or SMS. That's an episode full of learning. Now you're ready to answer the assessment part of your module. Do you have questions, ideas, suggestions, or clarifications in mind? Please do not hesitate to contact your Mathematics 8 teacher. I would like to take this opportunity to thank our ever youthful Dr. Vivo, the principal of Marcelo H. Del Pilar National High School. Of course, the assistant principals, especially our department head, who never get tired, Sir Marco Eusebio, magandang umaga po, as well as Ma'am Donna Estacio. Also to my colleagues from the junior high school mathematics department who are now watching with us. Thank you so much. And of course, this Teleradio episode will never be possible without the technical working group with Ma'am Hilda, Ma'am Bernadette, Sir Paulo, and Sir Frederick. Mabuhay po kayo. Maraming salamat po. I am Sir Richard, your Mathematics 8 teacher broadcaster for this week na nagpapaalala mula sa Love Radio. Una, magdasal ka para mabuhay ka. Pangalawa, mag-face mask ka para mabuhay naman ng iba. Yun, again, this is Sir Richard, now signing off.
Teleradio is always at your service. Kaya naman, ang feedback mo, suggestions nyo ay mahalaga sa amin to improve our programs on air and online. Para alam ni teacher yung strengths as well as the things in your mind na mas makatutulong sa mas effective na pagkatuto sa Teleradio. Please take time to send your feedbacks via Teleradio Mu, which you can access by scanning the QR code on the right or typing the URL provided here, bit.ly/3ORVAY9. One more, this time you follow. bit.ly/3ORVAY9. Kaya send your hashtag TBH o hashtag RT dito sa Teleradio Mu kung saan ang feedback mo, suggestions nyo ay mahalaga sa Teleradio.
Makinig, manood na sa Teleradio. Makinig, manood na sa Teleradio. Teleradio, Teleradio Marcelo. Sa gitna ng mapanubok na panahon, magkahatid sa kakibat ay diskusyon. Sama-sama tayo, kahit magkalayo. Sa programang ito, tiyak ang pagkatuto. Teleradio, Teleradio Marcelo. Teleradio, Teleradio Marcelo. Teleradio, Teleradio Marcelo.